Let's use a truth table to prove De Morgan's first law, which is given here. So what we do is break up these Boolean expressions into simpler ones, using a truth table. So first we have x and y, and then not x, not y, and then we have x and y, and then not x and y, and finally not x or not y. So the possible values for x and y are false and false, false and true, true and false, and true and true. So therefore not x is not false, which is true, not false is true, not true is false, and not true is false. And not y is not false, which is true, not true is false, not false is true, and not true is false. So x and y is false and false, which is false, false and true is false, true and false is false, true and true is true. And not x and y is not false, which is true, not false is true, not false is true, and not true is false. And not x or not y is true or true, which is true, true or false, which is true, false or true is true, false or false is false. So as we can see, for all these combinations of values, for x and y, the Boolean expression on the left hand side, which is this column, evaluates to the Boolean expression on the right hand side. So as you can see, we get the same result in every row of this truth table.